We are up and running. We're going to go through the presentation, and we'll have followed up with some code example. I think any Spring presentation without code, I don't think goes well here. So we'll get that done towards the end, so that we keep you here busy. How many folks use RabbitMQ? Just get an idea about. Oh, that's good. Okay. How many of you use Spring integration? Probably everybody. You're in Spring conference. That's good. So we're going to see some of the use on how Spring integration and RabbitMQ works together. I think there are a lot of different use people have it, and we wanted to kind of share some of the use, how we did it at ETRADE. My name is Durai, and this is Manish. So we built this. We have the tech folks in the architecture team at ETRADE, and Manish.
Yeah, I'm working with architecture team at ETRADE.
Your mic is off.
Sorry. So if everybody can hear me now?
Yeah.
Yeah, I work with the architecture team in ETRADE with Durai.
So we are excited to be here presenting. This is the first time we're presenting in Spring conference. I think the ETRADE everybody knows. I think a lot of people here hopefully have accounts and all using it. ETRADE is a pioneer in trading platform, which we built a while back on the electronic trading. Let's talk about on the agenda. So what we wanted to show is to give a background on what we have done in the past, and what are the things that matters to us during this whole evaluation of moving our existing platform into the new one, which we were going to share, and how we solved it, and then followed up with a demo, some code examples on the services we built. Okay, and we'll take some Q&A towards the end. We'll hopefully try to answer most of your questions. Some we may not be able to, so we can follow up later. I wanted to start as telling a story. It's kind of good to kind of start as a story to tell. And once upon a time seems like a pretty long time, but it's really not. I think in the information age, we think that as days and months goes by, it seems like a long time. And so we are talking about over a decade. Here we have been using a service-based architecture. So that's why I kind of came up with this slide. So it's more like a fairy tale story. There is a happy ending, but our journey doesn't end. It kind of continues as we progress along. So I think I kind of start with that journey. We are early adapters of services. I think before even web services became pretty popular in the industry. I think web services these days, REST services. There are many different flavors of services have been built. At ETRADE, we built this a while back, where we built on some other things, some vendor-based, some proprietary stuff, which we have built. And so it grew up into a large set of services. I think you can imagine that, if you start accumulating things over 10 years plus, so you end up getting a lot more code. I think people who are in the industry, representing enterprise computing, so you would really see as any company, grows along the way, they can end up taking more and more stuff. So what we did is that over the period, built everything and anything is actually a service. We don't have any functionality without a service, and then that ended up creating more and more services which are granular in nature. So because we wanted to reuse a lot of the functionalities, there are different endpoints which are requested from either through web or internal applications or different functionalities, different gateways. So there are large number of services grew as we built our functionalities. Part of this exercise, we also end up creating more type of payloads we had to support. So I think there are different type of payloads, and some in proprietary nature again, because of the way we built it from the beginning. Some are more common in XML, JSON, all kinds of stuff. So we have a mixed set of formats and payloads. We started using it. So that's kind of the background on where we were. And so as we started looking at, okay, let's try to revamp the, we built this, it works extremely well. It meets it, but there are always these issues about, how do we kind of bring a new type of development? How do we make things much more productive for our developers to really work on it and then deliver the needs? And how do we leverage some of the things happening in the industry? How do we bring that cool technologies into our platform? So as we started looking around, so we wanted to keep our things work so extremely well, keep that, and then continue to look at ways to improve. So I wanted to kind of walk through some of the key requirements we did. We looked at it, and then based on that, we evolved into this new platform. So that kind of sets an idea about what are the things we looked at it. So starting with performance, I think this is a no-brainer. I think every website needs it, every product needs it. So this is nothing big here for us. So I think some story to kind of share with it. I think there was a test done in Google and Bing a while back, and they presented that report on what was the outcome. So what they did is that everybody does a search. When you do a search, you expect the result to come really fast. Okay, what if that results come a little slow? I think they did an intentional slowness test for a few weeks. So usually that results something along like 50 milliseconds, you get a result. And it ended up coming like probably close to 400 milliseconds. So that's a huge difference on the response time. So as they did this test over the period of 7+ weeks, they saw that the revenue started going down. And sometimes after that test was completed, they never saw some of the customers back. They lost the customers during this whole test. So that's kind of gives us an idea. I think they did this exercise, but then probably after that, you see these results that are mind-blowing, right? This 400 milliseconds sometimes is still fast, but people don't like it. They don't like anything slow. So you don't want to see a sign like this, loading and all the time. That is not something good. So we need a way to execute our transaction pretty fast, pretty well, pretty accurately. So that's very important for us to do that. So the next one, burst load. I love this card. There is no other reason to put this picture here other than this. So burst load, this is another set of feature. We really need it because there is a condition where you have a market open, things, suddenly floodgate opens and everybody is onto it. And there is a Thanksgiving Day, you have a huge sale going on. There is some cheap product, something is available. And as you saw today morning, there is a new phone out, and that's next week or whenever that's going to come out. Everybody wants to order. So there are times which are triggered by events, either news-driven or something else, where the load is going to be coming into your site, and it's going to be peaking, and it's probably 10 times, 20 times, you'll never know. You may have enough capacity planned, but that doesn't really help sometimes to kind of meet that. So you want to kind of structure your deployment in a way that you can meet any such demand, 0 to 60 in no time, That's a very key requirement. And another thing I want to talk about is the service chain. So remember, we talked about a lot of services we have developed. There are like thousands of stuff that's available. As you have more and more granular services, you end up having a service chain because you don't have one functionality where everything is in one. Obviously, you don't want that as well because that kind of impacts your execution cycle. So you wanted to break it down, but when you break it up into multiple, you end up creating this another way of doing things is service chain. When you create service chain, you don't want that to do serial invocation. Sometimes you may have a dependency, one service calling in another service and expecting a data and trying to make use of it. Sometimes probably it's not. You just make a call, get some data, and that can be done in parallel. So you want your platform to be able to kind of do things as needed. You want it to meet the SLA. You want to be able to have an ability to process them in parallel and have a separation. That way you can really achieve the SLA you wanted. And another thing I wanted to highlight here is that we try to emphasize sometimes trying to keep it in context. I think, when you have a distributed architecture where you have all things in different places, you start losing some of that ability to kind of keep that response time on, meeting your SLA. So you wanted to be able to do as much as things possible within the same context. That means it would probably be within a process boundary or a node boundary or a domain. However you like to differentiate that, you could keep it within the same context. Sometimes probably it is not possible to do that. You may go out of that as well, which is fine. So the next one on services being simple. So that is one of the core things we started from the beginning when we started building our services long time back, is that we wanted to keep services to just do business logic. It shouldn't think about anything beyond that. You want to keep things simple so that your developers' productivity go up. Then they can test their code independent of the platform, because you may have a complex system deployment. You can do all that stuff in production or other testing environment. But as the developer works on it, they want to be able to do things much faster, much quicker. So you want to keep that. When if you are in Java, it's POJOs driven. If you are in other languages, you may do things which are specific to that, and you leave the container to do the heavy lifting. I mean, that's where some of the things we're going to later on see how Spring integration and other elements helps us to achieve that. Okay, so keep service simple, and do the business logic. And I think this is pretty much a lot of things known, and we kind of religiously follow this model to try to keep that way. Separation of concerns. So that is, I kind of briefly talked about earlier. We do get, this burst load of things, and we wanted to keep the queues separated out. So we don't want everything to be coming to the same tunnel, and that creates the bottleneck sometimes. So you want to be able to prioritize your queues, keep them separate, so that there are important service. Let's say you're trying to buy something. Buying an item may be more important than checking out where is the next the available store nearby. So you want to be able to have the separation, keep that independent, so that let's say that a lot of people are suddenly looking at something which is not probably critical to the business, and maybe those things can be separated so that they may have a different SLA than your critical functionality, business functionalities. So having that queue-based system really is important for us to achieve the goal. And the other thing in this is also we wanted to keep things process level isolation as well. So that way you don't have any impact, any service that impacting another one. So that's what it is. And finally, I think the things that matter, we wanted to look at languages that are not something we have started with. I think the beginning we did some C-based, Java-based services, but then as things grow, I think there is tremendous interest in the industry where there are new services coming, and new languages are coming, and people are adapting it, people are learning it. There are a lot of functionality available on some of these new languages. Another thing is that as we look at it, the services which can be written on, let's say, Node.js, can work much better than some other services, let's say, because it does some task very well compared to another language. So that is, I think, an important thing. We all started looking into it, seeing that, okay, how can we leverage, how can we build a platform that allows us to build services on a different languages. So we kind of want to build a common platform that we can plug in with a different set of services. So that really helps us to kind of divide the work and then do that with different implementations. So that kind of summarizes where we are in terms of our search for building a new platform. So we wanted to be lean, we want to be fast. I think that's critical. We wanted to meet all our business needs. We want to be able to run our existing set of services as well as the new one, because that's one of the core, and then also meet all the other needs. Okay, so that's kind of the summarizes it. And let's show now how we did it. This is our way, in the sense that it's not everybody's way. This is what we think it works well for us. So we wanted to kind of show you our way. So we looked at the background in the sense that how we did it a while back, and then what are the things important to us, and now we'll look at how we did it. Okay, I think this says it all. I think many of you might have already read this. We looked at it as a Bible. Really helped us to kind of open up to see what are the possibilities are. Somebody has already done the hard work. Thanks to these guys. It's amazing work on this is to help us to figure out, what are the ways we can do it, what are the patterns exist. I think people might have solved it in different ways in different time frame, but having this really helped us to achieve it. I think one of the thing I really like about in this is climb check pattern. I think there are many different patterns really work. This is one of my favorite is that, we try to solve messaging as a way to do things. But then there are a lot of inherent problems sometimes when you start loading huge amount of data, or not in terms of request, but if you have like 10 MB of data you're sending, sometimes, or a large amount of data in some cases, messaging has a way of slowness and producing great result as the payload size increases. So this pattern, by following, you can offload things into different ways. You don't have to go through multiple hops. You end up doing in a distributed architecture. So you can avoid that. You can get it. But there are a lot of other good things. So what we did is, when we started this project, we got a bunch of books. Everybody got trained. And we got everybody on the same page so that they can all work together within the team, achieve the ultimate goal on how to build the next best platform. So the goal is to build lean services platform. I think there are a lot of different vendor products, open source products available. So we had to kind of look at everything possible, but then we need to kind of not just take one, but we wanted to be able to take the ones which works best. So if you look at it, Spring does extremely well as it is. Messaging works, RabbitMQ works. So there are different modules and the platforms which kind of really helps us to build, works independently well, and then when they all come together, they also work well. Rather than having a huge, big monolithic platform you build it, we wanted to keep it very lean, work effectively, and meet all the things we wanted to do. So this also helped us to build existing services which we have built over the period, because there's so much investment already happened, and we wanted to be able to bring all that here and also support the modern services. So what we did with is that we picked RabbitMQ because we looked at a lot of different products, different messaging solutions. This one worked much better for us because of the nature of the spec itself. The AMQP spec really helped us. The binary protocol allows us to work with a different client, because we have a need of connecting from your Java client may be sending to a service which are written in different languages. We want to be able to bind them together in a way that it's decoupled. At the same time, they are all working together well. The performance was really good. We are able to scale up to a large number of connections. I think there are other solutions which works well in messaging, but if you start increasing number of connections, what happens is that it doesn't go beyond certain limit. So the reason we had a large number of connections is that since we are running with C, Python, and different set of languages, they're inherently like process-based, and there are a lot of processes running, and you don't have an option of doing your thread pool and creating smaller number of connections and then trying to work with that. So we want a freedom to go as far as possible, whatever required. At the same time, not really lose issues with respect to the slowness or any other thing. So RabbitMQ worked really well for us. It works with many different languages. I think there are 10 or 15 different languages it supports. The other thing is amqp extensions, which are built into RabbitMQ, really helps compared to some other alternatives, is that we are able to leverage the alternate exchange as well as the DLX for handling error conditions and routing to a different type of setup group of services. We're able to take care of all that by making use of AMQP extensions. It also runs on different OS. It helps us to do that. And finally, the support. I think having both open source as well as commercial support really helps us to do that. I'll take the question at the end. Is that okay? Yeah, thanks. So next on the Spring integration, as we saw, the EIP patterns, I think we really wanted to have a product that that works well and it's lightweight. It also be a service host. Okay, so many of the ESBs, I think, try to do a lot of different things, and I think it works for many people. It doesn't have a way of hosting services in some cases. Some cases they do. For our need, we built on Spring, and I think everybody loved to do development on Spring. This one fits right into our way of development, and it's pretty lightweight compared to all the other options we looked at it. It has an out-of-the-box support for RabbitMQ, so you have all the templates, your Spring templates available to connect into RabbitMQ. And you can actually write services as a Pojo. You don't have to do anything else. You can just write Pojos, get plugged in, and it's all configuration driven. So you have all this different config available for you to configure and do that. So you can do that if you're using a Spring STS. You can actually do the whole flow in the IDE as well. That really helps for people to design this applications. If they have to do multiple different flows, they can plug it in into the system. It has a lot of different handlers, and it has a nice JMX support built into it. These are some of the highlights on what we thought was built into the Spring integration. There are a lot more. I'm excited to see from the last night keynote, there is a new Spring integration is coming. And overall, the Spring I/O seems to be pretty exciting as well. I think you guys must be all exploring that. So here is the architecture, how we end up putting together. It has enough things, not all the details. There are a lot of other nitty-gritty details. We have not put it together to keep things simple here. So if you see here, there is a client. The client can be in any different languages. It's making a call into this bus, and it goes through a security layer. I don't want to get into that details on the security. But when it gets into the messaging layer, we have a lot of different queues available. And within a queue, you have a process which could be, here you are either in C or Python or SI based. And they would be connecting into the same queue, or they may be connecting to a different queue, handling the same service. So you could, let's say, an example, you're migrating an existing application into a new one. As you do this, you could do a phased approach. You may be running everything on legacy system, and messaging using the same messaging. As you write new services, they are hooked into the same queue. They are dequeuing off of the same queue, making use of that data, and responding it. As you'll see the demo, you'll be able to see how both of them are connecting into the same queue and processing it. And if there are issues, there are error conditions, they all go to the different exchange. And we have a special consumer process that takes care of it. We have a process manager that goes through all of these and manages the process. We have admin and monitors and the registry and all the good stuff with that. So it kind of gives you a high-level picture on how this architecture came together to help us. Now let's get into how we integrate web services. I think we like Pojos, we like to do that model, but we have written a lot of web services as well. There are a lot of good framework out there, and that really helps our developers to build them. But how do we integrate that into this system, which are kind of message oriented, and it's SI based? How did we achieve that? So what we looked at is that we wanted to use it as an ideal rather than a full-fledged container. Remember, we wanted to keep things lean. We wanted to keep it simple. We don't want all the bells and whistles of the whole container to do a lot of different things which we may not be using it. So we wanted to do things which are specifically take the web services that are standards based, bring those things, run it on this container. Okay, so we were able to do JAX-WS, JAX-RS, take that and then put it into this. So what it allows, we don't want to reinvent a different language or a different standard to do it. Follow the standard. Everybody has done the hard work, and making use of the same standard, follow all the tools and everything. And you will see a demo on on how we did this and how does it get plugged into SI. We're able to do different transport as well, on top of AMQP and other than as well, we're able to do. Here's an example of a JAX-WS. I think this is no different from any JAX-WS service you might have written. So you have all the same annotations, you build it, and then you'll be able to kind of get that running. And an example of JAX-RS, it's the same way. It's pretty much standard JAX-RS service implementation. You would do it, and that gets plugged into SI. Briefly, I want to talk about the DSL. So part of this exercise, I think, Spring integration works with RabbitMQ, all the web services. So what we learned as we did this, there are a lot of configurations sometimes you have to do with the Spring integration. Some configuration is good, but sometimes when it goes beyond certain level, you don't want to repeat same thing over and over again. So we had to do some extension on the namespace provided by SIs. They've done a lot of good work, but there is a way where you can extend the namespace. So that's what we have created, a new DSL that allows us to simplify the config so that we have a pattern, we have a conventions where when we create these web services, they can get dropped in much quicker with less config. So we wanted to keep things simple. We wanted to also, if there are things needs to be complex in the sense that you want to be able to create a new channel inside the Spring flow, or you wanted to build a new adapter, a new marshaller, you still have all the options possible. Okay. So here is one of the example. It's hard to read, and that's actually the whole point, is that there are different sections you have to do when you do like the inbound gateway, marshaller, unmarshaller, this your service activator, all the Rabbit connections, everything. So to get this working, you need to do all this config. So instead, we end up creating something like this, so where we extended the namespace available provided by SI, and we create our own inbound gateway, which follows the conventions. Okay, it takes a look at all the interfaces, takes a standard interface available by either JAX-WS or JAX-RS, and extend that with the convention. So we internally create all these channels, all the marshalling, unmarshalling, everything get plugged in by default. You still have everything running, but when you write the config, you don't have to do all the stuff. You just make it as simple as that. By doing this, we are able to also leverage all the tools. You have WSDL to Java, Java to WSDL, all the bindings available, and the transport we are able to leverage with the WSDLs. So it really helps us when you have some of these definitions written. So when you share with the other different groups, you can actually share the WSDLs and get a lot of those things generated out of the hand rather than doing a hand coding most of the code. So we're able to continue use all the regular web service development with the same platform. Payloads. So I think as AMQP is getting integrated into this platform, we wanted to make sure that all the different payloads works over there as well. So we are able to run different media types in the JAX-RS implementation. We're able to make use of the JAX-WS implementation with the SOAP and plain old XML and other formats. Here is kind of the flow if you're doing like a web service. How does that get integrated into it? So the request comes in to the RabbitMQ and then eventually get to the direct channel of SI, and it lands into an inbound gateway. I think that gets the message, and then you have a dispatcher which passes that message on and into the handler, and then end up into the service implementation. The service implementation does the work, sends the response back. And in this channel, there are a lot of other details as well, but you can actually get into at any point and plug in an additional handlers if you need to do it. You can do that as well. So that's kind of covers the top on how we did it. So let's get to a demo. We'll show you how some of these services work, both JAX-WS, JAX-RS, and also new languages. So I'll hand it over to Manish.
Yeah, thanks. So I hope you enjoyed all the propaganda now. We are going to get into the gory details. So let's see. the RabbitMQ management. So, okay, I need to get to Chrome. Okay, so basically, I'm going to show you, like, I don't know how many of you have seen a RabbitMQ management console, but they come, this is out of the box with 3.x RabbitMQ management consoles. And so essentially, you have a few set of exchanges already predefined, one of them being amqp default, amq direct. And so we just show you that, okay, these are the default exchanges. We don't have anything here. So let's start our set of services. We're going to go to the command line, my favorite place. So, so while the service starts in the background, we'll see an exchange startup here. And if I've prayed to all the gods properly this morning, there you go. You got a Spring 1.2 direct exchange. And then you see we've configured this exchange with a few attributes, being dead letter exchange. You've got an alternate exchange. This is a durable exchange. So basically, the idea is that I want to test a particular setup with an exchange being already there or an exchange not available. And then you have bindings. And how did these bindings come? Because I started my service. So I got like one queue, and then there are 3 methods or 3 operations within it. They are manifested as routing keys called get account, get accounts, and then there is like a REST URL type of exchange. Sorry, this is queue. These are queues, and this is the routing key. Okay, so how does all this happen? How does all this magic happen? So I call it magic because, okay, you got to do something besides just plain old SI. So essentially, we looked at a clean slate PowerPoint presentation, but this is how sometimes your API looks like, which is all gory and messy, and you've got a parameter SOAP binding web service. This looks like an ordinary web service. I mean, we could have written our own IDL. I mean, we could have written and developed tools for writing those IDLs and exchanging information. I need a place where I want to see the request. And so the request is basically, maybe I should just do it this way. And so if you look at this is a plain, it's an interface, but it has all these monsters around it, web result, web method, and this is a JAX-WS interface. All it does is basically take a parameter, an ID, and give you an account request object, and that's a JAX-V object, right? And there's another one right here. So, which is again looks very gory, but it's actually again just a simple interface. And I'll demo how to write a new operation here. So, and then that's your interface, and basically we are using nothing but Java X-WS here. It's not dependent on any framework. It is not dependent on any, but you get WSDL to Java tools out of the box, the industry, and then you can create bindings for various languages. And then if you look at the implementation of this class, we basically have again just because it's nice to do an implements of the interface, but it's just basically an implementation of this class. And then if you look at the implementation, it is just implementing that particular method, and it doesn't have all these annotations around it. It's kind of nice. So this is for JAX-WS, and I'll just quickly blaze through, I guess, the JAX-WS client. It's not the way usually you write tests, but this is nice for the demo because you normally would do assert. I got some asserts there. But OK, if you run this, you kind of understand how the output is on the screen. We have the same thing for JAX-RS. I mean, the manifestation of JAX-RS, especially like if you think about REST services, they are supposed to use the underlying protocol. So actually, AMQP or RabbitMQ extensions has basic publish and then basic consume and get. But we just took the simpler approach that, OK, we have these annotations that are already there from JAX-RS, which supports HTTP. So you've got get, and you've got all these nice things that you see even in Spring controllers. And again, these are, again, Java X extensions. We're not inventing anything here. And then essentially, you got a implementation of it. So let's probably run one of these and then make it interesting. I went over the Python, but we'll get to that. So let's just do, if I have all this running. So I'm just running a JAX-WS service. And shows a lot of stuff, but let's just go through it. And I get a response back. Very nice. So now we'll run the same test with the JAX-RS service. So everything works through RabbitMQ. And I've got a result from there. So now what we'll do is OK, all this is very nice, but how do we actually add a new method, right? I mean, maybe all this is just demo, but maybe things are not happening as I'm showing it. So live, and I'm crossing my fingers. OK, so this is read only. So I'll go over to a place where I have editor rights, so to speak, so modify service. So here, what I'm going to do is I'm going to add, I guess, OK, let's just write the interface first. Maybe I don't want to redefine the model, so I'm just going to write the model again here. Get accounts, and then with no parameters. That's all an interface is at the end of the day. And then we'll add the monsters part. We'll just put web result. And then since we are using bear, we can just do account requests. Sorry for using such a primitive editor, but it kind of works. And then we do @web method. I got some nifty stuff here. Equals, let's see, let's just call it simple get accounts. And that's it. That's my interface. So I can copy this over to the implementation. I'm just going to put it anywhere and start my and so hopefully I have declared a list of accounts somewhere that I can make. Yes, OK. So I'm just going to make use of a list of accounts that I have. In fact, I can just do this. It should be good enough. And that's it. I've implemented an interface. And I'm going to make modifications to my client. Let's see. And this is another part that I really like. I can, well, OK, I'll just take the stub here. I kind of commented it out somewhere so I don't torture you. And that's it. What I'm going to do now is I am going to just run this test so that the other tests don't run. So the way it works is that I only use the interface here. So I just have to do client.getAccounts, and then everything would just work because the interface is a dynamic proxy, right? So let's run this. So hopefully it will not probably give me, oh, there you go. It's, that's my account list. That's what I added. And it looks like everything works. So, well, this is something that I was very happy to do. I'm very proud of, because we didn't have to go towards an IDL. We did not have to develop a stub. We didn't have to develop services. It just works out of the box, and it works for JAX-RS and JAX-WS. So I'm able to serve both legacy systems, like if there are SOAP services coming in, or REST services, and also make it work with Spring integration, which means I can make use of all the different patterns, EIP patterns, which are available with Spring integration, quite flexible. But the fun part here is that, OK, we said something about making it language agnostic. So making it language agnostic was interesting because, OK, I mean, we have lots of bindings to RabbitMQ. One of my pastimes is to write some Python. So I said, OK, let's just write a Python server to to demo that, OK, I can run Python. So on this system. So it is the same server that you saw with Java. I'm just going to run this. It's just awaiting requests. So what we're going to do is to run the Python client there. That's going to make 10 requests to the same service. So well, I started this, so I should show you. I'm sorry. Come on, tab. So I should show you that against get account, I should now have 2 consumers. So it shows 2 consumers. And one of the consumers is the Java consumer, which is this one. And this is the Python consumer. It's just got different semantics. It uses different libraries. OK, so I got 2 consumers. Earlier, there was 1 consumer. So now I got 2 consumers. And now I'm going to run the green stuff, which is the client. So we earlier ran the Java client. Now we're going to run the Python client. And voila, we get all the results back. But the fun part is that I got 6 messages here. And so there was some sort of a load balancing that happened. Like 4 of those messages went to the Java service, and 6 messages went to this service. So if you see the Java service, this is the Java service running in the background. It got some messages, which is 4. You see the ID start. And then the other guy got 6. So this is like blind round robining that's already supported in RabbitMQ out of the box, which is a strategy. You can plug in your own strategies with RabbitMQ plugins. And we basically also do QoS. We do all sorts of fun stuff. But this is something that is good for a demo. And I'm kind of like done here. If you have any questions, yeah.
Thanks, Manish. Yeah. Just the last one to cover, and then we'll take questions. Isn't this awesome to see? Like, you have Python running side by side with Java, then you have all the other options. So I think we really feel this is kind of really opens up a door for a lot of different ways of implementing services, and not lose track of all the investment you already made in the enterprises. Going back. Somehow it went to the previous slides. That's interesting. OK. Next steps. So we're looking at different options, different things we are looking at improving. We're pretty excited about seeing some of the features coming out of the Spring I/O we looked at last night. Very interesting things because they're looking at not just individual components anymore, looking at overall platform. So we wanted to take a look at it more closely, see how does that really help us to build our platform. In summary, this model works for us. That's what there are different options available on the table. There are different ways of solving a problem. This one really works for us because of the need we have. and the performance works awesome. We have it running in production. It really works well. And the services that are async based really helps us to manage the load in a different ways. Not look at all the time, synchronous execution. It does. We have to do RPC semantics in some cases. We do that as well. But there are other options now available as we move towards this model. And decoupling of endpoints, the client, is another important ways of really managing our system. And this platform able to run both, like legacy. And I'm repeating again because that is some of the key things. Many of the software when you go off the shelf doesn't really help us to provide. So that's some of the key things. And we're able to bring heterogeneous environment into a more homogeneous container. So that's the beauty. And here I'll break for questions. As you see, yes.
Can you talk about your deployment, just in terms of how things are set up at a box level? Say, do you have servers in one place, RabbitMQs in another place? How does that work? And then maybe you can just talk about the throughput, on like a per installation basis that you've been able to achieve.
I don't have all the numbers per se, but RabbitMQ, we have different ways we have kind of tested in terms of configuration. We have multiple different instances connecting to a single RabbitMQ. We have a distributed RabbitMQ systems. So we're currently we are doing RabbitMQ and then all the services connected to one. But we have a more different model we are playing with it. We haven't really gone into that level yet.
So for ETRADE, you have a single RabbitMQ instance?
No, not single. No, there are multiple deployments, but we are looking at.
So you're clustering it in that way.
Yeah.
You have, a number of app servers talking to one, and that's like one cluster.
Yeah.
And then you have multiple.
Yeah, different type of clusters we have. Yes.
So you have multiple consumers, right?
Yeah.
How would you say which consumer receives the message? Or is there a way to track what's going on?
That's right. I mean, you can do tracking with various ways. So we're working on some things like speed tracing, and you can hear me. Sorry. Yeah, you can do tracking like in various ways. For example, we might have various channels of input, and we basically do something which is similar to the distributed, large-scale tracking system, like speed tracing. We put it on the headers. We know where things are going, so you get a breadcrumb of stuff.
Right. When you say it's an asynchronous messaging, right? It's
Right.
queue. So I have your Python client, which is dequeuing. How would I know it actually dequeued? Like you got thousands or millions of.
Well, I think in a deployment system, it's not going to be like how would you know? I mean, we would have complete control about where things are going. That's the way we probably be deploying it, right? So the security there's channels that we basically define. So it's not going to go where it's not supposed to go. You can have a collation of events that are happening.
I think my question is, how can we guarantee, how can I track that the message is received by the consumer? So, right, it's in the queue.
Mm-hmm.
For example, I have two consumers. One was your Java client, the other one is Python client. I have like 4,000 messages coming like a burst.
Mm-hmm.
Then how would I know all 4,000 messages are received by? I mean, is there any tracking mechanism built into MQ, or are there any plugins which help me?
There's lots of plugins that, at least for me, I've always debugged with, like, I don't know, with production deployments, I wouldn't be in a situation where I wouldn't know where my messages are going or not going, because I would know exactly where they're going. I have, for example, even in RabbitMQ, you've got a tracing plugin. So you can know where the message was published, who received the message, and how it got published, republished back to which IPs. You can also say, okay, my routing keys were started by this IP. This was received by this queue on this consumer. You see the consumer list when I showed you in the demo. You see a consumer. You see the number of consumers, and you see where the IPs are originating from. And you can also see how many messages got ACKed by which consumers in which IPs. So there's a lot of there are a lot of tools there which you can use already from the RabbitMQ management console. But I think for production systems, you want something that automates this, right? So you basically can query the RabbitMQ system itself, from what I know. I mean, I basically also have to depend on L-Shift. L-Shift is a company that's behind RabbitMQ.
Yes.
In that slide where you talk about why RabbitMQ, you went through a series of reasons behind the selection for RabbitMQ.
Yeah.
Could you contrast that against IBM's MQ and kind of give us some synopsis of where the gaps are with the IBM MQ?
We don't want to get into those details of comparison, so we do use some other product as well. But for this particular need, RabbitMQ works extremely well. But we do use other products for messaging, different type of messaging.
So was your decision more so that you already were a Spring shop, so it made it easier for you to integrate with RabbitMQ?
No, I think Spring integration really was based on some of the Spring usage. We were very happy with the way we use Spring. But RabbitMQ itself was not because of Spring. It works well in conjunction, but it had its own merit just as a messaging product. So we do use other messaging product as well. So this is not an exclusive use, but we do use for different needs. But in this case, it really fits the bill.
One final question. So you described this as an asynchronous model, but if you have a true batch-like application which works within a window of time,
Yeah.
would you still deploy this model, or would you make some improvisation?
That's where we are going. We are looking at ways to deploy batch because I think it really helped. Everything, as I said in the presentation, everything is a service. Including our badges, everything goes through the service model. So we currently use it in a different places, but in the future we are planning to use that as well. I think it works well. I think a Spring Batch is one of the candidate. It really does the job. So we are experimenting that. Yep.
How do you ensure messages not being lost, right? What type of production are you having any distribution of the keys? So that it is difficult to figure out based on the actual application what it is doing to figure that out.
I guess it's a similar question. So messages lost. I think that's the product's offering. Product. That's why we are not building a messaging product. We are not in that business. So the product takes care of that of delivery, and we have a way of tracking the different layers, whether the message reached or not, and if it is not, there is a error condition so that we make sure there is a message, response is given to our customers. So there are different layers. We have a way of check and balances.
Checks and balances instead of transaction management?
No, the transaction management, we do it at a different ways. That's more in terms of an application within the applications. Does that answer? Yeah.
I'm looking for your experiences. So can you tell something about the security aspect of the data being transmitted? How do you guys manage?
Yeah, sorry, I can't talk about the security aspect. No, that's. There are different options available with RabbitMQ with the security, and that's a big topic in terms of security, and especially being in the financial company, it's hard for us to get into those details and explain in a conference.
What are the options of securing the channels?
Securing the channel? Which channel?
The queues.
Excuse me?
The queues or channels.
So there are built-in support in RabbitMQ, which allows you to secure your the messages. So there are plugins available. You could extend if you don't like the ones which comes default. So you can make use of it. Whatever fits your need internally to your company, you could use that.
And what are the decreases of performance by doing this?
There is a, but you have to do it. There's no other option. So
Probably have different options.
there are different, yes. So, but for what we have built, this one meets our need. That's what I want to go back. It really works. The performance is good with what we have built with it.
how do you guys determine like how many exchanges you need to set up, how many queues you need to set up, how much data we want to pass and all that?
Yeah, that is based on the deployment for each instance we configure. So we look at it based on the functionalities and how we group these services. So based on that, there are queues, and within the queues, how many consumers are going to be there. So those requires like testing based on the needs, and different deployment have a different configurations. So it's not there's a one way of doing things. So you have to run your test, see for this functionality, how many, what's your capacity you're going to look at, how many queues it acquired is going to be determined based on your testing criteria.
So you won't run your test before the production. That production is completely different. So you have to know upfront like this is how it works.
Yeah.
This is my roadmap.
Yeah.
So anything if you have any suggestions in that area, that's what I'm trying to.
No, I think having the queue, right? Multiple different queues really helped us to manage the burst load, and so that is an important thing.
How?
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 What do you mean?
Having different queues helps you manage the burst load. How?
It's because the calls are made into those different queues, so we're able to split the request into different sets and different instances, and that's really helped us to do that.
Okay.
Yeah. Yes.
Do you support unit of work transactions within your domain? For example, I'm not sure if you guys are going against heterogeneous databases, but if you are in your services, supposing your service has to make a call to two different heterogeneous databases, do you manage the unit of work within your well, or is that controlled differently?
I didn't quite get that question though.
I mean, my question is typically if your service was making a heterogeneous call across two different databases,
Yeah.
do you have transaction management built in?
We don't do heterogeneous.
You don't do that.
Yeah. Yes.
Earlier you showed your methods for namespace, ETRADE. Is that including whether or not the service is exposed as a synchronous or asynchronous service? That is in the namespace implementation?
Could you just elaborate a little bit? What I heard was
I saw the demo where
Yeah.
it was a JAX-WS, JAX-RS annotation, but where do you specify whether the service is exposed as a synchronous or asynchronous service?
a synchronous or an asynchronous service? Okay, so that's depending on whether you write an inbound gateway. An inbound gateway will be an RPC semantics, right? So if you're going to write an adapter, then it's going to be asynchronous by its very nature. So we have namespaces for both. So if you have inbound gateways, then it'll be RPC semantics. But the service itself doesn't know and doesn't care how it's going to be configured. It just gets dropped in. Right, as opposed to, I think, what you're thinking about is future objects from async services in JAX-WS world, right? Yeah. So that's another good part.
Okay. Thanks everyone for coming. Yeah.